Welcome. So this is going to be an intro to Substrate talk. My name is Bruno, and I'm an engineer at Rogue. I'll talk a little bit about Rogue at the end if you're interested. And that's a picture of me right there. That was in my past life when I worked at Parity Technologies. So the agenda today is we're going to discuss about what is Substrate, the definition of Substrate, the need for a blockchain framework. Why do we need a blockchain framework? And talk about how building a blockchain is hard. We're going to go into the Substrate architecture, a bit of a high-level architecture of what Substrate looks like. We're going to discuss state transition functions and how that relates to Substrate. We're going to take a little bit of a deep dive into Substrate, not too technical, but a little technical. And why Substrate? Why you should use Substrate? Why your business should use Substrate? Why developers should use Substrate? And if you're sold, then how to get started with Substrate. And then finally, we're going to end it with smart contracts on Substrate and how you can deploy your smart contracts on a Substrate network. Audience here is its actual general audience. It's for newcomers, new developers that are coming into the ecosystem, but also for seasoned developers. I think that they'll find this presentation entertaining. Audience is also for founders that are shopping around and looking at different techs for building like blockchains, right? So hopefully I'll sell this to you. And blockchain enthusiasts, of course. So after 2 years of being a Substrate developer at Parity, this is the definition that I came up with. That Substrate, it's an open source, battle-tested Rust framework for building future-proof blockchains optimized for most use cases, built by developers for developers. Another definition of Substrate is this. So this is the Polkadot SDK repo. And if you look all the way to the bottom here, it's actually cut off here in my slideshow, but it's, let me escape here. There's a red arrow here, I don't know, very tiny. It's actually the Substrate folder, okay? And inside that folder is all of Substrate. All right, so that's where Substrate lives, that's its home, it's inside the Polkadot SDK repo. So that's another definition of what is Substrate. So why blockchain framework? Why is Substrate needed? Well, building a blockchain, when you're building a blockchain, there are several components that are common in most blockchains, such as like database, networking, transaction queue, consensus, cryptographic primitives, and if your blockchain's really cool, light client support, right? So you don't want to be coding that from scratch. In fact, building a blockchain from scratch, it's really hard, and it takes a lot of resources. It takes a lot of money, takes a lot of time, and specialized knowledge. So you're going to have to hire people with very specialized skill set, including like veteran engineers that can architect the blockchain. So Substrate takes a lot of those components, the common components, and abstracts it for you. And it's built in a generic manner that all of these are built into Substrate in a configurable and customizable way. So you can change, as a developer, one can change any aspect of these. We're going to focus on the last bullet point there, the state transition function. So keep an eye on that. This is my artistic rendition of Substrate. So Substrate is composed of two main parts. One is the node, and the other is the runtime. All right? Those are the two main parts of Substrate. The node aspect here, you can see they're the most common aspects that we're talking about the blockchain. So you have the RPC server. RPC server is like how the world communicates with the blockchain. You have the lib peer-to-peer library, so how the nodes discover each other, how the nodes gossip to each other, transaction pool, host functions, and all these common components, including telemetry. So how's the blockchain doing? Is it doing well? Is it suffering? Like what's going on with the blockchain? And then, of course, you have the runtime. So the runtime you can think of, it's the business logic. It's where one would write all their business logic. They have their how they execute the blocks, what their blockchain does, and what's considered an account on your blockchain, what's considered a balance on your blockchain. That's in the runtime. So here's another view of it. So here you can see this is the runtime. A developer would code the runtime in Rust, and then it gets compiled down to a WebAssembly runtime. So a WebAssembly blob that's more efficient. This WebAssembly gets uploaded to the chain. and the chain, the state of the chain is held in the database. Okay, so keep that in mind. So state transition function, the runtime, the Substrate runtime is essentially a state transition function. So how does your blockchain transition state, right? That's the logic that would go into the runtime. So for example, maybe your runtime has some cool logic that does staking. The developer would have to write that code. The developer would have to write code if you want to transfer from one account to another. There would have to be state transition logic for that. And that goes in Substrate, that goes in the runtime. We write that in the runtime. So here's another rendition of that, right? So you can think high level, there's your runtime there. Right? So most use cases for blockchains, they're there in that pink kind of area. We'd be writing there. So let's look at it in a different way, right? So here we have accounts. We have Bob. Bob's got 100 dot. Eve's got 0 dot. Alice got 0, and we're at state n. And then we have some logic in our runtime that allows for transferring dot, right? So in this case, we want to transfer 10 dot to Eve from Bob, because Bob's got 100 and Eve's got 0. So that logic would get executed. That logic would live in the runtime. It would get executed on the chain. And all of a sudden, you have your new state, n+1, which would result in Bob having 90 minus fees and Eve having 10 dot. Let's expand it a bit. So in reality, the instructions, these transactions, they come from the outside world. I like to think of them as commands that are coming from the outside world to tell the blockchain, hey, do this or do that, right? And in Substrate, we call those extrinsics. And so an extrinsic could be sent, say, transfer from Bob to Eve, 10 dot. Okay, so we send that, and then the blockchain, the Substrate blockchain, has logic that will execute that. First, it'll check if it's valid, then it'll execute it, and once it's executed, the state changes. So extrinsics, actually, they're inside blocks, and typically there's lots of extrinsics within a block. There's a vector of extrinsics, and you can think high level, each extrinsic is, say, do this on the chain, do that on the chain, do this on the chain. And the runtime would check if it's valid, and if it is, then it would execute that logic. And once again, here you see blockchain executes it, state changes. So state was n-1, state becomes n, right? And then it would proceed to another block, which contains another vector of extrinsics, different extrinsics, right? So that's how the chain is moving. So if we look at this diagram again, it actually, even if we can this is already kind of baked into Substrate for us, and it's if all of our business logic is going to be on the runtime level, it still takes a lot of Rust code to write custom block execution logic, to write what an account is, a balance is, and to write the custom business logic. And there's a lot of custom business logic that not a lot of chains, but there's a lot of similarities between chains, such as, I'll give you an example, staking, right? You don't need to reinvent staking. It's already, so in Substrate, you already get that, all right? So you can either write it all from scratch, your runtime all from scratch using Rust against the Substrate library, the Substrate node, or there's a framework within Substrate. There's framework within a framework. It's called Frame, okay? And Frame, it stands for Framework for Runtime Aggregation of Modularized Entities. That's a mouthful, blah, right? It's the framework to build runtimes. And I have here that it allows one to build runtimes faster because it requires less lines of code, less lines of Rust to write in order to create your business logic, your use case on the runtime level. So Frame consists of these Rust modules that there are these encapsulated Rust modules that you can encapsulate your business logic. You can organize your business logic. And we call these Rust modules, we call them palettes. So they're known as palettes. So these palettes are there's different types of palettes that you can use, and I like to think of them as kind of like Lego building blocks that you can use to construct your runtime. There's also some support libraries within Frame that aid the runtime development. So this is the same diagram, but in a Frame world, right? So you see your runtime now, and you got Frame. So now you got a concept of these palettes. Here's a palette that has system library stuff. This one defines what balances is on your chain. This one defines what staking is on your chain. This is governance. And there's one here, NFTs. And you can see they're each a palette, what we call a palette, a module. They're each separate. They're encapsulated pieces of business logic. And you can, the way that frame works is that they get amalgamated via this macro here called construct runtime. This construct runtime will take all this and create your runtime. And then this is also provided by frame. It defines how to execute blocks. So all of a sudden, building a runtime got a little bit better developer experience there. One note too is like host function and runtime API. You can see that there's this dotted line here, right? You may wonder like, why is that separated there? Well, if you remember the runtime after you've written the code, after you've configured your palettes, it then gets compiled to WebAssembly. So you have this WebAssembly blob, right? So this WebAssembly blob, it still needs to communicate with the node. And the node sometimes needs to communicate with the WebAssembly blob, the runtime. So the way that that's done is via these two interfaces. The host functions, when we say host here, you can think of it's synonymous to node. Okay, so you can think of this as like, this is the API that's defined on the node for the runtime to communicate with the node. That lives here in the host functions. So if the runtime wants to communicate with the node, it does that via the host functions, all right? And then we have the runtime API. That's the other way around. So if the node wants to communicate with the runtime defines a set of runtime APIs. Hey, this is how you can talk to me. So if the node wants to talk, it talks via the runtime API. So what are these? These are palettes. So in the Substrate framework, within Frame, there's these palettes. These are just a few. They're not, there's more, all right? And what's cool about these palettes, like maybe you'll see some there that are interesting. Like for me personally, I like the NFTs palette. It's pretty cool, especially with the new NFT features that we have in Polkadot. So the idea would be like you take whatever suits you here to build your chain, your way, right? So one thing to note about these palettes that are inside the Polkadot SDK repo is that these are audited. So you get that peace of mind as well. So here's a different way to look at it, right? Like, so you're, as a developer, you look at these, okay, I'm going to create a runtime. It's going to have EVM. It's going to have a treasury. Like, there's a whole bunch of palettes. So I invite you all to look at that Polkadot SDK repo and look at the palettes. One thing to note is I have this custom here, right? So the frame way of doing things, the Substrate way of doing things is that you're not going to have everything like already built out for you, obviously, because you're going to have a unique business case for your chain, right? So in that case, like the workflow is for one to create their own custom palettes. So Frame allows one to build custom palettes and in that way, in that manner. So this is a different view of the same thing that we've been looking at, but with Frame, right? So why WebAssembly blob? Maybe one of you or a few of you in the audience have been thinking about this. Like, why does it get compiled to WebAssembly blob? Well, the reason is that Substrate was built from the ground up with Forkless upgrades in mind, right? So so right here in the database, there's a key called :code. That's actually the name of the key in the key value database in Substrate. It's called :code, and the value of that key is that WebAssembly runtime blob. So if we're thinking in terms of Forkless upgrades, if we want to upgrade the Substrate chain, all we have to do is replace the value of this key. That's it. So let's look at that. Like, for example, right? So here's the key, :code. It's 0x77, right? So that's at the key value database in this particular state. And then in the runtime, we'd have some STF, some business logic, that would do that swapping for us, for that key. That's really what it's doing. And boom, it gets swapped, right, if you want to upgrade your chain. So what do we upgrade there? What is the idea? It's that, okay, so say you want to add a new feature to your blockchain, right, on the runtime level, right? So you want to add a new extrinsic, you want to add a new function, whatever the feature may be. Maybe your boss, maybe your manager, whoever, comes and says, hey, we need to add this feature because they added it. So if they added it, we need to add it, whatever, right? So you can do that. As a developer, you can just go there, code a new runtime, add that new feature, compile it, get the new WebAssembly blob, and execute the upgrade, and you now have a new WebAssembly, a new version of your blockchain there. So think about that. In non-substrate ways, it's very common, like these legacy upgrades, where if one wants to upgrade the chain, they have block 101, block 102, and then they say, hey, upgrade. Well, what would happen there would be that the binary of the chain, the feature would be coded, and the binary of the change would change. So either one would have to discuss with node operators offline how that update will occur. Hey, everybody, you're going to have to use the new binary on this date, right? And maybe that works. Maybe that'll work, but it would be an off-chain type of thing, off-chain discussion. Those are lengthy normally. Or maybe you have some disagreement and they say, hey, we don't want this new update, so we're going to continue with the current binary. We're not going to upgrade to the new binary. And then all of a sudden you have a fork, right? So that's pretty typical. Whereas with the Substrate way, with the Forkless upgrades, one says, hey, upgrade my chain. And what happens is the WebAssembly blob gets updated on a chain. Node operators don't have to replace any binary. They don't have to do anything. It's seamless. And so if you look at Polkadot, it already upgraded many times. Polkadot is a substrate-based chain. So you can upgrade again and again and again and again and again and again. Okay? Now, who can do the upgrades, right? So with Substrate, you could have, there is a palette called super user do palette, right, sudo, where it's like one entity, could be one person, one account that decides to do the upgrades, right? Why does this palette even exist? Because like we're all about Web3, right? Decentralization. Well, when you're starting out your chain and you're building things out, it's common that you may want to start with a pseudo palette and slowly build out your governance system. So Substrate has a number of palettes for one to build governance, really nice palettes. One could start out simply with palette collectives to create a collective on their chain that's a governance body that is in charge of the upgrades. Or one could take it a step further with like palette democracy, and there's a number of other palettes within Substrate to build a more complex governance system with voting. So you have a voting mechanism. That's all available to you. So hopefully, up until now, I've sold you on some features for Substrate. But let's talk about a little bit like why Substrate, just like a review. Like in my experience, I recommend Substrate for founders and developers because it's future-proof. Future-proof in the sense of the forkless upgrades, right? So you're not shoehorned into a corner of like you built your blockchain and it's like really difficult to upgrade it. With the forkless upgrades, you can continuously upgrade your chain. And also, Substrate puts writing your business logic in terms of runtime level business logic, it puts it on a pedestal. So the developers don't have to focus on like the intricacies of a cryptographic primitive or lib peer-to-peer gossiping. They just focus on the business logic. And with Frame, one can do that. The other reason that I think is really amazing is that the community is really strong. So there's currently, when I took this screenshot, there were 49 parachains on Polkadot in production. These are Substrate-based parachains. And then there's another 47 on Kusama in production. So there's a production-level Substrate-based parachains that are in production. That's, if you include Kusama and Polkadot, the relay chains, that's like 100 parachains that are Substrate-based parachains in production. That's pretty good in my opinion. And if you include Rococo, the testnet, there's 53 more. So if you say, okay, like I like this Substrate tech, I want to build a team around this, right? Like, how do I get started? Like, well, we're going to discuss like a little bit more of the docs, but one way that I'd really recommend is there's a Polkadot Blockchain Academy, and there's a couple modules in the Polkadot Blockchain Academy that are Substrate. And so if you send your team to the PBA, your team will come back super skilled in Substrate. So how do we get started? So right now there's Polkadot SDK docs. It's live. Substrate, like when I came into Parity a couple years ago, that was one of the things that amazed me, how well documented Substrate is. So with the Rust docs. So like if I'm stuck in a function, I open up the repo and I search for that trait, and there's Rust docs on top of that. It's really well commented. And the Polkadot SDK docs is also available, and it has documentation on Polkadot specifically, on Substrate specifically, and on Frame. So today I just gave you a high-level primer on Substrate, but in the docs, it goes very deep into the technical nature of Substrate. There's also templates available in the Polkadot SDK docs. So if you want to hit the ground running, there's some minimal blockchain templates. There's also a kitchen sink node that has like most of the palettes configured. So it's a great reference template to see how to configure palettes. And if your team gets stuck, we have a vibrant community with the Substrate Stack Exchange. So we have our own Stack Exchange. There's a lot of great questions there. And it's a great place for one to ask questions and get feedback. So I've been talking about the runtime, and there's also the node, right? So one is free. If their innovation is to modify the node, you can do that. It's built in a generic way that it's customizable. The only thing is that the learning curve, I would say, is the hardest. If one wants to have their own consensus, a different consensus system, that's, if you see the development time and complexity time, it's available. One can do that. It's the hardest learning curve, but you can do that with Substrate. As far as like, if one wants to build a blockchain without framework, it's less hard, but it's still hard. Lot of Rust code. You have to really understand, like, okay, how do I craft an account? What's the balance? Block execution logic. So that's available. It's a little bit hard, but not as hard as, like, I would say modifying node stuff. But really here, like, this is the intersection. This is where I recommend if one wants to build a blockchain with Substrate, building with Frame. I find it enjoyable just because the way that I look at palettes, it's organized in a certain way. Like, you have your storage, you have your extrinsics, that I can reason about my code in a very clear manner. Okay? So I would say this is the sweet spot. However, building a blockchain may not be the use case for everybody. Right? And Substrate actually has a solution for that. So not many people know, but you can have smart contracts with Substrate. So if you want to invest in your team and you want to start with a business case and you can solve it with a smart contract, I recommend that. You start with a smart contract. You start with Ink. So Ink is an EDSL language. It's a programming language. You basically write your smart contract logic in Rust. So you write your business case in Rust, and Ink compiles down to WASM, WebAssembly, and it deploys on a palette in Substrate called palette contracts. So you need a Substrate chain that's running palette contracts. So if you can solve your business use case with a smart contract, you start out there, you skill your team up with this Ink, and then from there, if you want to create something more unique that's beyond a smart contract, beyond the smart contract sandbox, then you can scale into a blockchain. And you still have that Rust knowledge with your team. So you're investing in the Substrate stack with Ink. But how do you deploy? Where do you deploy? So that's where the company that I work for, it's called Rogue. That's where we're kind of playing around with two things, and I'm going to end with this. So Rogue is building a POP CLI. You can think of it as a development tool for Polkadot. So we started out, investigating what are the issues with Polkadot. Developer experience was a big one, like that there's a tool here, there's a tool there, there's a tool over here, and it's like really hard to like piece it all together. POP CLI allows you to like spin up a parachain template or spin up a smart contract template, build your smart contract, test your smart contract, run end-to-end tests, deploy your smart contract locally, it spins up ZombieNet. Deploy your parachain locally, spins up ZombieNet. And it also deploys it to the network. POP CLI, that's one tool we're building. The other one is POP Network. So it solves a problem like from people coming into the ecosystem and say, hey, Polkadot's pretty cool. I want to deploy to Polkadot. Where do I go? And it's like, well, you can't really deploy to Polkadot unless you're building they're like, well, we don't want to build a blockchain. We want to deploy a smart contract. Well, there really isn't anything like that. Right? Well, you could deploy to one of these parachains, but it's not So POP Network is a .native chain. We use .token, and it solves that pain point where you can deploy it to a Substrate-based chain. It's a parachain, and use . All right, so if you're interested in learning more about that, there's a lot more that Pop Network does. There's a QR code. You can get some updates there. That's our Telegram for Pop Network. Thank you.
Perfect. Thank you so much, Bruno. So we do have a bit of time. Does anyone have any questions? Okay.
Substrate.
Substrate? What is a substrate? Okay. No worries at all. Yeah.
Luke.
So with the POP CLI, is that like scaffolding a front end that interacts with smart contracts that are deployed through the contracts UI if you want to do the smart contracts, or you can choose to spin up like a Substrate node template or something as well? Like you got that choice?
Yeah. Yeah, you get the choice. So like you can, it's very simple. It's just like if you want to create a new contract, you say pop new smart contract. There's templates also. You say pop build, it'll build a contract. And then pop up, it'll spin up the zombie net and deploy. So there's actually a talk tomorrow on this if you guys are interested about all that stuff. Yeah.
And the second question would be, I saw the Pappy talk. Is it adopting the Pappy template, or can you choose like a Pappy template or the legacy Polkadot.js kind of?
For the smart contracts?
Yeah. Just in terms
for the parachains.
In terms of the front end interaction.
For front end development.
Yeah.
So that one we're just focusing right now on the back end at this point. Yeah. So it'll spin up like if it's a parachain, there's different parachain templates. So like you could have an EVM template, you could have an NFT template. So we're gonna integrate more and more for the templates, and same thing with the smart contract, the Ink templates. Like the Ink library has a bunch of templates. We're looking to integrate with all of those. So we're also open to collaboration because we're just starting out. So if you have any ideas, drop it in the channel.
Thank you.
Thank you.